Hello and welcome to another Out of Spec Reviews video. You join me back at EVS 36 for another video. If you guys haven't taken a look at our full tour that went up just a few days before this video will be posted, and I took you, basically, if you weren't able to come through every booth, we looked at everything, we talked about the main topics happening in the EV industry right now, this big push to support the North American charging standard away from CCS, which I am absolutely pushing as hard as I can for, and kind of everyone else is too. They're like, yeah, this is the better connector, so I love that. One thing in that video you may have noticed if you watched it was we came by Tritium and I said, got a little bit interrupted. I was just talking to some viewers here and I was like, you know what, we're going to come back and film a full tour on what Tritium is doing. Tritium is one of the longest running names in the DC fast charging business. We've used them for years and years. They've been around for almost as long as anyone. And I thought, you know what, they have a really cool new product line. Products that I've never seen before that I think you guys are going to be interested in. They have some engineers here that we can nerd out with. And I was like, you know what? Let's take the opportunity. Let's do a full video just on Tritium, their new products. Probably not going to be a super long video, but I think for those of you who like charging electric cars, you'll be really into this. Tritium, of course, is another company to support the Tesla connector, the North American charging standard. And gotta say, that's freaking awesome. Can't wait. So what we're going to do is get some representatives from Tritium on YouTube with me right now, and we're going to go on a full tour of their new products. And honestly, I don't think anyone else is doing solutions like this in this way, and I'm really curious to see what you guys have to say about it. So comment below with your thoughts on Tritium's new product line. Well, we're over here at the Tritium booth and it's always busy. And of course, we've seen some of these chargers out in the wild. We actually charged on this one here, the RTM, and this is available in a few different power configurations. This is an all-in-one unit and definitely want to talk about this unit. It's interesting and it works great for certain applications and we'll learn about what those applications are. But this PKM, which looks almost identical to the RTM over here, actually is completely different inside, completely different use case. No AC to DC conversion inside the actual dispenser here. It's pretty interesting, and that's what we're going to get into today. So you join me at Tritium at EVS 36. Let's mic up some of their colleagues and dig into what makes these products special. I also want to talk about Tritium's past a little bit with them, because we've used the old 50 kilowatt, the RT50s, for years. I've been seeing them on YouTube well before I ever started even making electric car content. And so, yeah, now's the time to talk about Tritium's past, present, and future. Guys, I'm with my friend Jack from Tritium. Jack, thanks for joining YouTube.
Yeah, happy to be here.
And dude, well, first of all, you have an unbelievable booth here. You're like the center of attention at the show.
Thank you.
Why is everyone here? What are they here to see? That's what we want to get into today. So tell us a little bit about Tritium first.
Yeah, Tritium's been around for about 20 years. We founded in Brisbane, Australia, then came to California via LA. We've been manufacturing fast chargers since around 2012, 2013. We have behind us, though, our new product line. We have our PKM architecture, so this goes up to 150 kilowatts. And then we have our RTM architecture that is 75 kilowatts. So that comes in 50 or 75 modules. This is our PKM 150 with 100 to 150 kilowatts of power.
Nice. And we've also seen some advertisements from you, or some brochures, I should say, that you can support even higher power into the future. What does that look like?
Yeah, we have some exciting stuff on our product roadmap. We're looking at a PKM 400. That's probably this year or next.
Wow, so very soon.
Yeah, and then we're looking at megawatt charging. And we're even going to some smaller module type stuff around probably the 25 to 30-ish kilowatt range for fleet deployments, fleet electrification, things like that.
I think that's really smart. Not everything needs to be crazy high power, 3 megawatt plug-in.
Yeah.
I want to talk a little bit about Tritium's past, because you guys, again, were one of the first ones making reliable, cold weather tested DC fast charging equipment. For those of you who aren't familiar, Bjorn Nyland in Norway had been traveling using Tritium chargers for a long time.
Yeah.
The old screaming units, the 50 kilowatt ones.
Yeah.
What took you from that unit to now this new design? What's that changeover like? And do you even still make the old RT50s?
We are ending production on those.
Okay.
So our legacy products are entering end of production. They'll still be supported and whatnot. We want to make sure that people are able to use them, still charge up.
Yeah.
But we are very much gravitating towards our modular architecture. the reason for that new change is we just found a really big need for a high level of serviceability. So previously, you'd have to go out to a unit, send a bunch of different people to lift out a power module, do a bunch of heavy lifting. You're probably looking at like 2 service techs at minimum.
Oh, wow.
With our new architecture, you have a power module that can be single person lift, very easy for them to swap in and out. You can do it in under 5 minutes. And then as part of that, you also have greater kind of power redundancy, where if one of those modules fails, the whole system stays up. That charger is just derated by that small power block. And then you can just go kind of switch it out and get the unit back up and running.
So let's start with your more traditional charger, which is
yeah.
the RTM AllinOne. You said 50 or 75 kilowatt versions.
Correct.
In a previous video, when we picked up the Coda Electric, we charged on the 50 kilowatt one,
Nice.
And that worked out great. They're super quiet. Like, I was super into that. Why the power levels? How is it architected? And what's the use case for this charger?
Yeah, so this one, we can actually pop it open over here. So inside here, you see our power blocks.
Okay.
This is our 25 kilowatt modules each. At the bottom, since it's an all-in-one unit, you have AC, DC at the bottom here, and then DC, DC up at the top.
Right, so it's fed AC directly from the grid, all in one. All of that's done here. You have your DC modules here. I have to ask, I always see VFill.
Yeah.
What is VFill?
Yeah, it's just a legacy name that we used for our products for a long time, but then we sort of stopped using it as our public-facing name. It's just something that we trademark under for our IP.
I see. Okay, cool. But Tritium is the public-facing everything at this point.
Yeah.
And so this particular one, what is the power output? This looks like a full stack. So what's the power output of this? This is a 75?
Yeah, this is 75 kilowatts. So yeah, and we sell it in versions of 50 kilowatts or 75. So you just take out one module.
Sure.
And it's high level of serviceability, high level of reliability through it. And Tritium, for the life of the company, has always had liquid cooling as part of one of the differentiators. The company being founded in Brisbane, there's all types of creepy crawlies that can get inside chargers there, and we've gotten quite accustomed to that and solving for that. So all of our units are IP65 rated. So
even the RT50s were liquid cooled back then.
Correct.
How about that? That's cool. That's why they work so well.
Yeah, yeah, and there is a fan at the bottom, or sort of like a car radiator fan that's cooling the liquid, that glycol mixture that then pumps throughout the unit. You can see back here, there's like a green tube back there that's feeding some of the liquid coolant, and then it goes through these blue hoses into the actual power module, going throughout, forming like kind of a lake for different areas to cool down different components.
And that's some of the magic behind your IP is in the actual water cooling nature.
Yeah.
And for some of you guys who may not know, like some of the most reliable chargers on the planet, I'm thinking Tesla version 3 supercharger, charge points unit. We did a whole thing with them as to why liquid cooling's more reliable. It leads to some of the success for these power modules and why they can just rip. I'm a huge fan of eliminating ambient air transfer when possible.
Yes.
And so that's really great that you guys have that here.
Yeah.
So, okay, I think our audience is pretty familiar. Like, we can definitely nerd out with this a little bit more. The like really interesting thing to me is this. And so what is the difference between RTM and PKM, first of all?
Yeah, it's how it's distributed. So this is an all-in-one unit. This one's fed via power cabinet. The differentiator for our type of power cabinet is that we're taking it's no longer a 1-to-1 ratio. So you're not looking at one power cabinet to one charging station. You can connect up to 4 of these to one power cabinet.
Right.
And you're distributing that DC power across that whole unit. It's important because that power cabinet is being fed through the AC grid, which you have really large cabling.
Yes.
When you transfer that from DC, from the power cabinet to this unit, it's DC cabling. So it's much smaller. You're saving tens of thousands, if not hundreds of thousands of dollars in cabling costs, depending on the level of site you're developing.
Right, and so our audience can understand. I mean, we occasionally charge at all-in-one chargers, and we occasionally charge at chargers that are fed from a centralized power source and then distributed to a whole bunch of dispensers. And there's units like ChemPower coming online that's going to be doing that. There's, of course, Tesla's the most common example with version 3 chargers where they can link all of them together.
Yeah.
But ultimately, your solution's even more different than those because you're feeding DC, of course, directly to the end unit, but not matching the car's voltage. You're basically feeding power, and then it's up to this if we go to the other side, that has some actual
Yeah.
voltage matching situation going on?
Yeah, the easiest way I think about our power distribution and our architecture is we're creating a pool of power that is then able to be distributed at a very granular level to those vehicles. So it's no longer by, okay, there's a power module either behind a fence or within the unit that's distributing it at that specific power block. We view it all as like a large pool of power that's distributing it across from that power cabinet into these units and being fed at that granular level.
And what it means is this unit versus this unit over here can share power in as little granularity as you want in 1 kilowatt increments, because ultimately they're all getting the same DC voltage to the units. This is what's matching the car.
Yes.
And so you basically have unlimited availability to max out your grid connection, which is sort of next level, in my opinion.
Yeah, we like to call it oversubscription. So oversubscribing the power to the site. So whatever you have in the rectification side of things in that power cabinet, you're able to play with charging curves and actually use that power in a more efficient way. So if you're a network and you're distributing that across the vehicles that are charging on your site, you're able to play around with it and see, okay, this car is drawing this much, it's going down on that curve, we can start to amp up this much by that whatever granular level to fill in those gaps.
Sure.
So it creates just a highly efficient way for CPOs to distribute.
And we'll definitely talk to your colleague Caleb a little bit more about this and get into the nitty gritty. But ultimately, I think it's a fairly unique take on how to do distributed sort of power distribution. I love the idea. And before we kind of end with you here, I really want to know, like, what's the future of Tritium? Obviously, RT50s, we're not going to see much more new installation on those. This is the product line you're transitioning to. You mentioned this is up to 150 or 175 kilowatts?
Yeah, this is 150.
150. How do we get more power?
Yeah. Stay tuned, I guess, is the keynote. But yeah, we're going to have, our product roadmap is publicly available. We're going to have a 400 kilowatt unit, megawatt charging units, smaller units that are purpose-built for fleet charging and other applications. But I think we're just really focused on creating products that our customers want and that their customers want, because drivers in a lot of terms are actually creating that demand for our products via those networks and via those fleets.
Yeah, so it's all fed from the driver. You're just responding to what people are looking for. And US built and manufactured?
Yeah.
What's up? What's the story on that?
Yeah, that's the exciting bit.
Yeah. So in Tennessee, where exactly?
Yeah, we're just outside of Nashville in Lebanon, Tennessee. We've been manufacturing there since July of last year.
So almost a year.
Yeah, and NEVI units are coming out of there, which I think with the news with NACS is also kind of an interesting use case for us. So for our NEVI solution, you're looking at 4 of these with 2 power cabinets, so distributing 150 kilowatts per cord. But now that everybody's going to want to have NACS on those chargers, I think that makes a very strong use case for our charger, because you can have sequential charging, CCS on the one side, which is required from the NEVI program, and then NACS on the other side, and it's still going to be funded by the government. And it actually doesn't
even matter which one people plug into. You'll get your government funding if the US government doesn't change, which I think they're going to allow NACS for NEVI funding at some point. That's just my impression. We'll see what happens. But ultimately, you're supporting the Tesla standard. You're supporting what's the previous current standard in the US, and really excited to see this. So let's talk to Caleb. Let's nerd out a little bit.
Yeah.
But can't thank you enough for joining on YouTube. Appreciate the product presentation.
Yeah, thanks so much.
And really curious to see what our viewers think about this, because this is pretty wild.
Yeah, thanks for having us.
Thanks. Well, you joined me over at the RTM 50, right, Caleb?
RTM 75.
75, this one. And this is Caleb. He is basically the guru behind Tritium. What is your official title?
One of the principal engineers at Tritium.
So a lot of your magic went into this right over here. So pretty cool stuff. You have an awesome job creating hardware that's installed globally. And I want to know all the nerd stuff. You guys know we're all nerds. You're a super nerd, way more than us. And so we got to learn from you what is going on here, and most importantly, what's going on with the distributed system, because that seems next level craziness like we've never even seen before.
Yeah, so it starts here with our, I guess, unique architecture where we've actually got two different types of power modules in this system.
Yeah.
So we don't usually see this with our competitors. Typically they have one module that does all the power conversion, AC to DC to isolated DC.
Right, and so in the all-in-one, at least, you have your AC connections in, and it's a global product, so slightly adapted North American spec versus Europe.
Correct, yep.
And then you have your AC to DC chargers, more or less, or rectifiers here.
Rectifier, yep, modules.
And then DC to DC
charging
output.
modules.
Yeah,
yep.
Crazy cool.
Yep. So when you have a all-in-one, and this is only a baby, but you know, as they get bigger and bigger, it's not going to be used all the time, right? Like it's a charge station. People need to move their vehicles into place. They need to play on their phone before they charge. There's a lot of we call it diversity factor in EV charging. So if we have all of the hardware in one module right at the car park, it's actually a little bit inefficient. That's not being used all the time. It's a little bit wasted. Mm-hmm. So when we go to the DC distributed architecture, and this is the reason for splitting those modules apart, is that we can take the modules for the AC/DC and centralize them. So we put them into a shared resource, or I guess a common pool for the charge site. And once you've done that, you actually don't need all of the AC/DCs that you just took out of all those charge stations. You can throw away maybe half of them.
Right, because you're never going to run flat out on everything all the time, right, unless maybe you're charging big trucks that just, you know, take big power all the time. But for a retail situation, even probably most fleet situations, you know, you're just pulling peak power for 5 minutes, 10 minutes at most, and then the cars derate. And when that happens in an all-in-one situation, you know, this whole module might not even have to spin up, and it's just wasted conversion capability that's at your site.
Exactly.
And grid connections is such a big topic in the US, and maximizing a grid connection. So being able to basically maximize your grid connection across multiple chargers is the key of the distributed site. Now, you're still going to need all-in-one for certain small 1-2 chargers here or there, but having this distributed method is great. And we've seen other distributed methods in the US. Mm-hmm. Version 3 supercharging is the most popular, the most well-rounded. They have a DC bus between their cabinets. They can do site-level power shifting, very similar actually to that. Not totally identical, but pretty cool. And liquid-cooled, very reliable. So we're a huge fan of all of this. But also we've seen other distributed sites where maybe they go in 50 kilowatt chunks. Yes. Where, you know, if you have one car on one charger that's asking for 200, but the other car next to it's pulling 151, and, you know, it can't get that extra module over to the car.
Yep.
So how does it actually work between your AC to DC rectifiers working with the DC-DC side to get that 1 kilowatt granularity between dispensers?
So it's a DC reticulated system. So the rectification unit, which is full of AC/DC modules, puts out a regulated 950 volt DC link, which runs around the entire site.
So all of those lines can be super small compared to AC distributed.
You get the advantages of DC cabling versus AC cabling. So yeah, there's that, which is great. And then each of your charge stations actually has the second stage of power conversion equipment. So as it starts to regulate current into the car, it just loads that common bus, and it can load it as much as it needs to or it wants. So once it's done reaching its max power output to the vehicle, whether that's limited by the charge station or the vehicle, the other chargers can come online and use the rest.
Yeah, it's such a genius idea because, like you had mentioned, that real charger conversation with the car through the cable, that's all done at the last step where you're modifying that last voltage match, that current request is all done right up here on the dispenser. At least in that one over there, you just only have these here.
Exactly.
And like that is so cool to me, and it really helps maximize the grid connection.
Yeah, and people are really familiar with this idea of the grid connection being, you know, we call it oversubscribed, where you may have a small grid connection into a site, but you still want to have a fair few plugs so that people are not queuing for ages. So what we can do with the rectification equipment is that there's no point having more rectification equipment than you have grid feed.
Very true.
So we can actually throw out some of that AC/DC equipment, and you don't spend so much on power electronics.
We've seen so much wasted money in
Right.
extra conversion capability
Yeah.
than what the grid could ever allow.
And then, as the idea for our architecture is that in the future you get a chance to upgrade your transformer or your grid feed. You should be able to put more AC/DCs in there, so that equates to more energy transfer, more money charged to the customers.
Totally. I mean, it's just a great way to build a site that's scalable.
Exactly.
And what about the software to control all of this? Does Tritium provide it? Because in the case where you have a bunch of, let's say standalone units that you have, way more power conversion capability than the site allows, you need a separate box, if you will, that's controlling the maximum load and can dynamically derate.
Right.
And sometimes this is a different provider than the chargers, and it can get kind of confusing.
Exactly. There's an interface there. Yeah.
Yeah. So what does that all look like in the world of Tritium?
So of course, because we have a rectifier unit that is oversubscribed, we need to make sure that the charge stations can't overload it. Just like in the case that you were talking about with using a CMS.
Yep.
So all that power sharing software is native on our PKM product. So it needs to be there. We provide it. It's a seamless experience. The customer doesn't really know it's there.
Right. To the customer, they're just going to plug in, and it might pull everyone down a little bit if you're a little bit oversubscribed, and that's a great way to max out. And, we talked about this yesterday as well, a little message just to tell the user,
Yes.
Hey, in oversubscribed mode or derated due to maximum station demand. I'm not sure how you brand it, but it'd be a great way for nerds like us to be like, oh, that's really cool. And then you can walk over, unplug the guy next to you and get full power. Not that anyone should
It's frowned upon.
Yes, it's frowned upon. And then, on the topic of connectors and cables, this is the big hot topic of the show, at least in our market, is, we're sort of switching to the North American charging standard. But then we still have some, I would say, legacy, regulations and funding programs that are supporting CCS.
Yep.
How will this work through the transition period for you guys? You were one of the first companies to announce the North American charging standard. What does that process look like from the technical side of things?
Yeah, so we still got to go through, quite a few gates to be at the point where we're delivering chargers with NACS connectors. But it's all just work to be covered by us. So the interoperability is less of an issue because the CCS is common to the NACS connector. So
right.
So from a firmware point of view, there should be relatively trivial changes to the actual.
You just need cables to buy and
Right.
spec,
Yeah.
and there's none on the market that are
that's
UL listed.
Yep.
And
Yep.
so it's really on the cable manufacturers. So push Amphenol, they're right over there. Push Rima, push Brugg, push Huber-Schuner to get a Tesla cable out there that's UL certified, so you can sell that to charge point operators to get these out in the wild. But from the actual technical side of things, it should be the same communication. ISO 15118-2 should be the charger. You just slap the cable on and change the graphic on the front, and we're good to go.
Yeah.
Is the idea.
Yeah.
I'm oversimplifying, of course, but
Well, let's hope.
yeah. Can we take a look, unless there's anything more you wanted to discuss in here, could we take a look at the actual PK
Definitely.
situation? And so what is the naming difference between PKM and RTM stand for?
So originally RT was retail and PK was park, so more of a charging park
Okay.
situation. And the M is that now all our products are modular.
Oh, great.
So,
Yeah, very cool. And so this is a 150 kilowatt version?
Yep.
Okay, and that's just because you have all those DC-DC situations here.
Right.
So how does the power actually come in? Is the fan still at the bottom? What's going on different between this unit and the all-in-one?
It's actually almost the common chassis. So, and that was one of the advantages of going with this sort of architecture and roadmap is that we were able to just develop the RTM and then pull out some rectification, put it into another cabinet, and then fill the rest of the space with DC to DC modules to make
And that's cool because in the other charger, you have your AC-DC rectifiers here where you can just fill that space easily.
So some cool parts about having a DC input circuit. So that's a 950 volt DC input. And what that means is that the grid, which is kind of the most uncontrolled and random part of a charging site, doesn't come near this charge station. So we don't have to deal with any of the peculiarities of
like
actually,
frequency drop or
right,
spike loads
right.
or ripple effect or anything. Yeah.
This powers itself, even its auxiliary power is actually derived from the 950 volts. So,
oh, really? So you have a DC to DC booster to jump down to 48 volt or whatever you're running everything on?
Yeah, so this doesn't have to know about three-phase AC. It doesn't have to know about the grid fluctuations or any of that. It has a really nicely, smoothly regulated 950 volt input that comes into this charge station.
So that just means in terms of this thing lasting longer, it's not getting any crazy power sent to it because your big AC to DC centralized source, that's taking all the hits from the grid. That's right,
and it's hardened. Yeah, exactly. The other thing is that the energy available out there, that at the AC/DC, we're talking more about arc flash in charging now. So we have, with the grid, if there's a fault, an arcing fault in the charger, that can actually, when you get to high power levels like 350, 400 kilowatt, it can actually make a pretty big energy event. If you want to go on YouTube and look for arc flash incidents,
I have. Yes.
It's a serious problem. So
of course.
So with this architecture, again, that AC interface is further out. It's probably in the bushes, not near your car, not near your kids, where you get your kids in and out of the car. So again, the energy that's available to this unit is much more limited.
Right, of course, and just means more safety.
Yeah, exactly.
So obviously this is a 150 kilowatt dispenser. If you were to add more power, which we've seen in the roadmap, higher power up to megawatt situations using this architecture, how does that look from a conversion standpoint? Because you've kind of maxed out your chassis space here.
Yeah, so we'll go to a bigger and taller charge station. But the concept is very similar. And,
just adding more.
And we scale out rectification as well. So we'll have that common DC bus will be fed by multiple rectifier units.
So the one last thing I kind of want to leave on is cost, and not identical cost to each charger, because I don't even know if we can talk about, I don't know what they cost. In terms of general large numbers, when you have an all-in-one unit that has AC to DC rectifiers and then DC to DC, which feeds the car, that to me seems like almost twice the equipment in one unit. I understand the real benefit for this distributed system and for you to basically produce common parts across both product lines. But is it a significant cost increase to do this over your competition?
What it should translate to is relatively even, because we've got the DC cabling advantages. We've been able to oversubscribe the AC to DC, so we're using those much more efficiently. We have obviously it's the same power electronics, so you still needed to have all the power electronics in the site that you would have otherwise had. It's just an extra box and an extra cooling interface and some extra connectors.
Right.
Swings and roundabouts, it all kind of works out.
Works out to be roughly similar, and to the end user, it just means you're getting more power more of the time.
Right.
And so I'm all about that, and I love the idea of maximizing grid connection, distributing that in whatever increment possible. And actually, that brings up one last topic. Is it difficult to tell the cars in such little granularity how much power they can share and have? Do you have to manually do this in chunks?
No, that just works.
That just works. Yeah. That's amazing.
Negotiated by the comms protocol, the standard.
And the charger's just saying, here's my maximum, and that's changing. The car's going to ask for whatever it needs.
Yep.
That is so cool. Well, I can't thank you enough for the tour. Can't thank you enough for really all this magic that's gone on at Tritium. I can't wait to charge on one of these systems and watch it all happen and move around. So we'll have to do that. I want to go visit the lab that's in Torrance and do some nerd stuff with those guys there. But you flew all the way here for the event.
Yes, and I've had very little sleep. So.
Yes, well, thank you again for all of that. That was wonderful.
Yep.
And hopefully we'll get you back on YouTube at some point in the near future.
I'd love to.
Yep. And thank you guys for watching a tour of Tritium's product line and really the differentiation between these two units. Super fascinating. Want to see your comments down below. Another video from here at EVS 36. We'll see you on another one soon. Bye-bye.